Welcome back to the channel. Before we dive in, do me a quick favor and hit that like button. Subscribe to the channel and turn on notifications so you never miss out on our deep dives into the most cutting-edge technology. Now, let me ask you something. What if robots could move just like us, balance with the grace of an athlete, and think on their feet in real time? It sounds like something straight out of a movie, right? Well, today, we're pulling back the curtain on a machine that makes science fiction a reality. We're exploring Boston Dynamics' Atlas, arguably the most advanced humanoid robot ever created. This isn't just about gears and circuits. It's about the future of robotics. Let's get started. So, what exactly makes a robot advanced? It's a term we hear a lot, but what does it really mean? An advanced robot isn't just about being strong or fast. It's not just a powerful arm on an assembly line. True advancement lies in a combination of three key abilities: moving naturally like a living creature, adapting instantly to unexpected changes, and learning continuously from its experiences. Think about how you walk. You don't consciously think about every single muscle movement, you just do it. You adjust your balance on a slippery floor without a second thought. That's the level of sophistication we're talking about. And that's precisely what Atlas does. It's a master of all three, blending fluid motion, rapid adaptation, and intelligent learning into one incredible package. It's this synergy that separates Atlas from almost every other robot on the planet and pushes the boundaries of what we thought was possible. Let's get to know the star of our show, Atlas. Developed by the brilliant minds at Boston Dynamics, a company renowned for its revolutionary work in robotics, Atlas is a bipedal humanoid robot. That means it walks on two legs, just like us. But calling it a walking robot is a massive understatement. Atlas can walk, run, jump, and even climb with a level of agility that is simply breathtaking. Its entire body, from its legs to its torso and arms, is engineered to mimic the complex and efficient biomechanics of the human form. The secret to its incredible stability is a constant real-time balancing act. It's packed with an array of sensors, gyroscopes, accelerometers, and more, all feeding data into its onboard AI. This system allows Atlas to maintain its balance, even when pushed or walking on unstable ground. For a long time, achieving this kind of dynamic, human-like mobility in a robot was considered a distant dream, a challenge for future generations. But with Atlas, Boston Dynamics has turned that dream into a walking, running, and jumping reality. Now, let's talk about that balance and movement in more detail, because this is where Atlas truly shines and leaves other robots in the dust. We're not just talking about taking a few steps in a controlled lab. We're talking about extreme athleticism. Imagine a robot that can leap across wide gaps between platforms, landing with perfect precision. Or one that can perform a full backflip, sticking the landing like a seasoned gymnast. Atlas can do both. It can run across uneven, unpredictable terrain, like a rocky field or a forest floor, without stumbling. If you were to walk up and give it a hard push, it wouldn't just fall over. It would stumble, catch itself, and regain its balance in a shockingly human-like way. How does it do this? It's a continuous high-speed feedback loop. Using its stereo cameras and motion sensors, Atlas is constantly perceiving the world around it and its own position within it. Every single movement, every step, every shift in weight is calculated and adjusted in mere milliseconds. This isn't pre-programmed choreography. This is dynamic, reactive control. It's the robotic equivalent of muscle memory and instinct, all happening at the speed of thought. This is what we mean by robotic agility at its absolute peak. It's the ability to not just perform a task, but to perform it gracefully and robustly in a world that is messy and unpredictable. Of course, all that amazing physical agility would be useless without a brain to guide it. And that's where Atlas's artificial intelligence and perception systems come into play. This robot sees the world. It doesn't just sense it. Atlas is equipped with advanced vision systems, including stereo cameras and LiDAR, which is like radar but with lasers. This gives it a rich, three-dimensional understanding of its environment. It can recognize objects, identify different types of surfaces, like grass, concrete, or a wooden plank, and spot potential obstacles in its path. But here's the crucial part. It doesn't just see these things, it understands them. It comprehends the context of its surroundings and adapts its actions instantly. If it sees a box in its way, It can decide to pick it up or walk around it. If it needs to cross a narrow beam, it adjusts its gait for better balance. This is a fundamental leap forward. Most robots in the world today are limited to highly structured environments, like a factory floor, where everything is predictable. They just follow a strict set of commands. Atlas, on the other hand, is designed for the chaos of the real world. It doesn't just follow a script. It perceives, thinks, and reacts. This ability to operate autonomously in places that are unsafe or inaccessible for humans is what makes it so revolutionary. With all this incredible technology, you might be wondering, what's the point? Is Atlas just an incredibly expensive and complex piece of entertainment? The answer from Boston Dynamics is a firm no. While its acrobatic videos are certainly entertaining, Atlas is being developed with serious real-world applications in mind. Its purpose is to go where we can't, or where it's too dangerous for us to go. Think about disaster response scenarios. After an earthquake or a building collapse, an Atlas robot could navigate the treacherous rubble to search for survivors, moving debris and providing a critical link to the outside world. In search and rescue operations in remote wilderness, it could cover ground much faster and more safely than a human team. Consider hazardous environments, like a nuclear power plant during a meltdown or a chemical spill site. Atlas could be sent in to perform critical tasks, like turning valves or assessing damage without risking a single human life. Even in industries like construction, a robot with its strength and agility could handle heavy lifting and complex assembly in dangerous, hard-to-reach areas. The core idea behind Atlas is to create a tool that can augment human capabilities and perform work in the most challenging and unstructured environments on Earth. It's designed to be a partner, not a performer. So, why is Atlas such a significant technological milestone? It's because it represents the culmination of decades of research from multiple distinct fields. It's not just an achievement in mechanical engineering. It's a seamless fusion of advanced mechanics, cutting-edge artificial intelligence, and sophisticated control systems, all integrated into a single, functional machine. It's one thing to build a strong robotic arm, and another to write a clever AI program. It's an entirely different level of challenge to make them work together in a body that moves with the grace and responsiveness of a human. Atlas serves as a powerful, tangible demonstration of just how close we are to achieving human-level mobility in robotics. It closes the gap between the stiff, jerky movements we associate with old robots and the fluid, dynamic motion of living things. More than that, it's a barometer for how incredibly fast technology is evolving. What was pure science fiction just 10 or 20 years ago is now being tested in a lab and demonstrated to the world. Atlas isn't just another robot. It's a landmark on the roadmap of technological progress. Ultimately, Atlas matters for the future because it fundamentally changes how we imagine robots and their role in our world. For generations, our idea of a robot has been largely confined to two categories: the industrial arms bolted to a factory floor, endlessly repeating one simple task, or the fantastical, often menacing, humanoid robots of science fiction. Atlas shatters those old categories. It proves that a robot can be mobile, intelligent, and adaptably true physical agent in the world. It shifts the paradigm from robots as simple tools to robots as capable partners. This isn't a distant theoretical future we're talking about. It's happening right now. The development of robots like Atlas is accelerating, paving the way for machines that can work alongside us, assist us in our daily lives, and venture into places we never could. It raises profound questions about the future of work, our relationship with technology, and what it means to create an artificial being that can navigate our world as skillfully as we can. Atlas isn't just a machine. It's a message from the future, telling us that a new era of robotics has arrived. And that's a wrap on our deep dive into the Boston Dynamics Atlas. What an incredible piece of engineering! If you enjoyed this video and want to see more content that explores the frontiers of technology, make sure to hit that like button and subscribe to the channel. Now I want to hear from you. Drop a comment below and let me know. Would you trust a robot like Atlas in your daily life? What jobs do you think it would be best suited for? I can't wait to read your thoughts. Thanks for watching, and I'll see you in the next video.